Alright, if you're back, that means it must be time to move on to the next stage of the process, and we have 32 minutes and 41 seconds remaining, so let's move on. The next step is going to be to insert, well, all the rest of the mold parts. And this is really an amazingly automated and quick process. For this part, we're going to create a mold base, insert ejector pins, sprue bushings, locating rings, a lock set, and we might put some fittings in the cooling channels, but I don't know yet. So we're going to go ahead and start off with mold base. And when we click on mold base, it's going to load up Inventor's pre-built included library of mold bases and base parts. In this case, we're going to use a Futaba mold, which is a 2-plate SAS series mold base. It's going to be the 330 by 350 millimeter size, which just means that the workpiece, the largest workpiece that you can use is 330 by 350. Our placement reference for this will be just, I'm just going to use a point, one of the corner points right on the center line here, or on the parting line. And realistically, you could put it anywhere you want. I mean, you could put it right up here, but that's not really going to help you much when it comes to the creating your pockets and your base plate, or your cavity base plate and the core base plate. So hit OK, and boom. This is a lot of automation right there. And these parts are, every single one of these parts are here is an off-the-shelf part that you can just go ahead and order. And we need to update our runner sketch. You saw the little lightning bolt there. I'm sorry, I didn't call it out before I hit the update button. Because we added some new stuff, it wanted to update, so it showed a little lightning bolt. And to deal with the lightning bolt, come up here and click Mold Global Update, and that will update everything based on whatever new conditions you have. So we're going to go ahead and put in a couple of ejector pins, and when we go to insert the ejector pins, it brings us back just to our part here. And if it really mattered where we put the ejector pins, you know, we'd work on that in the design phase. For this, we have a lot of broad flat areas, so there's nothing here that's really likely to get damaged. This is probably not going to be a cosmetic surface on whatever part this gear would go into. So I'm going to put it here, and I'm going to put one here. Expand this out, and you can see I can adjust the X and Y locations. And I want this to be on Y0 and X 0.5, and I want this one to be at Y minus 0.5, or X minus 0.5 rather, and Y0. So that's going to keep everything nicely centered. And hit apply. And now, because you can see it's created our little ejector pins here. If I wanted to have an anti-rotation pin, I could, and I think we'll actually put one of those in. Since we're going to eject this, we have this nice big cold well here, I'm going to go ahead and put an ejector on it, and we'll make that one anti-rotation. So we're going to go ahead and place our ejector. We're going to go and put it right here on the bottom, right in the center there. And yeah, right there. Okay. And see, I've got it anti-rotation checked there. And you can see that it's got a flat right on the side there. So go ahead and click OK. And look at this. We've got our ejector plates down at the bottom and the ejector retainer plate. Set that. Okay. So now we can kind of highlight things individually here. And so you've got our ejector plate, which pushes on the bottom, on the flat on the bottom of the ejectors. Our ejector retainer plate, which holds them in place. And if we spin this around, come back here and look at the one that we created to pop the cold well. You can see it's a slot rather than just a hole, and the flat on the pin meets up with the flat there, so that keeps it from rotating. Pretty nifty. Alright, now we have to do sprue bushing. So we'll go ahead and click on sprue bushing, sorry. And again, these are all off-the-shelf parts. And in this case, it's the default is a Hasco Z51, which is good enough. I don't see any reason to use something different here. And we're going to do the placement based on the runner sketch, and we're going to pick a point. And in this case, it's going to be that point right there. And we want the sprue bushing to be a little bit longer than this, because you can see obviously it's not quite going to make it down to there. Oh, also you can see it's sticking up some. I can offset that in. And in this case, I know that the thickness of that head is it's 0.709 inches, because I've been using these quite a lot lately. So I hit minus 0.709, and now it's nicely flush. And I still need to make it a little bit longer though, so let's adjust the length parameter. 46, no, a little too long. 36, that'll work. This just means it would have to buy the 36-inch, or 36 millimeter, sorry, Hasco Z51, and then we'd trim it down a little bit. Alright, and SR, let's give it a nice little radius there. And again, these are all just default off-the-shelf things here. So we'd just give them the part number and tell them which options to pick, and it's going to give us, you know, the exact sprue bushing that we want. And you can see that, oh hey, look at that. I didn't do that right. We need to have a longer one. I'm sorry, I was thinking here that this was the parting face, but it's not. We need to go with the 56 millimeter one. And you can see that that sticks down almost 3/4, maybe more than 3/4 of the way through the cavity, or the core plate. But that's okay, because Inventor's going to trim it automatically. And you can see it made it all the way through, and now it's going to meet up with our runner system. And we'll put a locating ring in there too, which will go around the sprue bushing. And I want to recess this a little bit, not nearly as much, so minus 0.197. And again, that actually is the right offset for this particular type. But we can do others. We've got several manufacturers here that we can look at. So I'm going to go ahead and hit OK. And something on my sprue bushing didn't come through. I'm going to change the radius to 40 millimeter again. There we go. So now we've got our ejection location, or injection locations, our ejector pins, and we need to, well, we don't need to, but we can, and I'm going to go ahead and do it. We'll add a lock set. And I want to do a side lock on this. And we'll use the DME FW45. And again, this is just as simple as picking a couple of faces. We want to lock the mold base rather than doing the cord cavity. And our base face is, of course, going to be the parting face here. So go ahead and pick that. Our reference face is going to be the side where we want the lock to go. Put that right here. And we want that to be more or less in the middle. Yeah, it's close enough. Actually, let's go ahead and see if we can move it around a little bit, just so that everything has to go in symmetrically, or so that it can only go in one way. And we hit symmetrical placement, and you can see that one showed up on the opposite side there as well. So let's move you by 0.25. And that's not the direction we want to move. Don't want to recess that. So we'll move it 1/4 of an inch over that way. And go ahead and hit OK. And again, there you go. I mean, it's so simple. It's almost all just point and click and done. Now, let's go ahead and we'll add in some cooling channels here. And for this, we go back to the mold layout tab. But we'll get to this in a minute, so why don't we pause and you guys go ahead and see if you can get to this point, and then we'll come back and we'll do the final stages.